Welcome back to All This Math. This is Professor Parker. Thank you for tuning in. Please make sure you subscribe to the All This Math YouTube channel. Make sure you like this video. Make sure you share this video. And also, please drop a comment down below about this video. All right? So, and also, shout out to my alma mater, Morgan State University, where I earned my undergraduate bachelor's degree in finance. Because originally I never wanted to be a teacher. But becoming a teacher is one of the best things that ever happened to me in my life. Real talk. But at any rate, shout out to Morgan. I grew up in the community surrounding Morgan State. Morgan has been a fixture in my life throughout the duration of my childhood, my adolescence, and I ended up going there for college. So yeah, shout out to Morgan. Let's get into this problem. So we're about to solve an absolute value equation. All right, we're about to solve an absolute value equation. All right, now let's read it first. The absolute value of 3x minus 4 is equal to 2x minus 6. All right, so what you do with an absolute value equation is this. You got to set up two separate equations, right? You're going to drop the absolute value bars, and you're going to set up two separate equations. The first equation is going to look exactly like the original equation, just without the absolute value bars. The second equation is going to look similar, but what happens to what's on the right-hand side, everything on the other side of the equal sign, on the other side that did not have the absolute value bar, so basically on this right side, right, this expression, everything over here is going to become its opposite. That's what's going to happen in the second equation. And then we're going to solve both of those equations for our variable x, but then we're going to go back and we're going to check. We got to check our work to make sure that those solutions actually work in the original equation, because sometimes they don't. And when that happens, we get something that's called an extraneous solution. An extraneous solution. So you can't just say, oh, you know what I'm saying, I solved the first equation, I solved the second equation, those are my two answers. No, one of your answers might be invalid. One of your answers might be invalid because it might not work in the original equation that you started out with. So you got to make sure you check to see if your solutions, your two solutions, both of them, right, they got to both work in the original equations you started with. All right. Now, let's get to it. So, like I told you, but actually, let me back up a little bit because this does not apply in this equation, but I want you to still understand this. The first thing you got to do is you got to make sure the absolute value is isolated by itself. Isolated by itself. Now, because some equations you might have a number that's being multiplied by the absolute value, you might have a number that's being subtracted from it, added to it. You have to get rid of those terms first. You'd have to get rid of both of them first, or whatever else is over there, because you got to have the absolute value isolated. Now, it just so happens in this problem, this absolute value is already isolated, so you don't got to worry about all that. All right? You can go straight into creating your two equations. All right, so let's create our two equations. So, let's see. All right, so we're going to have our first equation. Boom. Drop the absolute value. Now we got 3x minus 4. All I did was drop the absolute value. And that's equal to whatever's over here. Everything stays the same. Equals 2x minus 6. Boom. That's our first equation. Remember, absolute value equations, and also with absolute value inequalities, you're going to have either two equations or two inequalities set up. All right? Then I'm coming over here with it. I dropped the absolute value symbol. I got 3x minus 4 is equal to now. Everything over here becomes its opposite. Everything over here becomes its opposite. So the positive 2x is going to turn into a negative 2x. The negative 6 is going to turn into a positive 6. Everything becomes its opposite. That's how we set up the second equation. So now I got negative 2x plus 6. All right, now let's get to work. Now it don't matter which one we solve first. It don't even matter. You know, matter of fact, I might, do both of them at the same time. Let's see how that works. Let's do, so I'm going to transpose. I'm going to have 3x minus 2x is equal to 4 minus 6. And I'm going to slide over here, and I'm going to have 3x plus 2x is equal to positive 4 plus 6. Now, this positive 2x moved over here. Now it's negative 2x. This negative 4 moved it over here. Now it's positive 4. Switch the side, change the sign. Switch the side, change the sign. Switch the side of the equation it's on, change the sign. Negatives become positives. Positives become negatives. Memorize that, right? Same thing over here. This negative 2x became a positive 2x. This negative 4 became a positive 4. All right? Now, the reason I did that is so we have the same type of terms together. Because when we do that, when we got it set up like that, now we can combine like terms. Because also our goal is to simplify the equation. There's no point to have 3x and negative 2x when you could just combine them into just 1x. Since 3 minus 2 is equal to positive 1, leaving us with 1x. That's the purpose of all that. When you're doing algebra, make sure you know the purpose of the steps that you're taking. Like, why are you doing it? Don't just sit in class and just try to memorize everything the teacher put on the board. Think and wonder, okay, why am I doing that? And if you can't figure it out, raise your hand and ask the teacher, like, bro, Mr. So-and-so, Miss So-and-so, why are we doing that? And make sure they know, like, you know, you're not trying to be disrespectful, but you like to know the rationale. So I would like to know the rationale behind that step because it'll be easier for me to understand and retain the steps in this process anyway. Let your teachers know. Hopefully they got answers for you. They might not though, but that's another conversation for another time. But you can always come to the All This Math YouTube channel and learn whatever you need to learn. I'm going to just let you know that. So 3x minus 2x is x. 4 minus 6 is negative 2. Make sure you know how to add and subtract positive and negative numbers. 4 minus 6 is negative 2. You need to know that. Over here, 3x plus 2x. That combines into 5x. 4 plus 6 combines into 10. All right, over here, this is done. Because I got an x equals negative 2. Over here, we got to get rid of this 5. How do you get rid of the 5? You do division. How do I know that? Because division is the opposite of multiplication. And this 5x means 5 times x. So this 5 is involved in multiplication. Since the 5 is involved in multiplication, we got to do the opposite operation to get it uninvolved. Right? So the 5 is involved in multiplication. So we got to do the opposite operation to get it uninvolved in what that operation that it was involved in and get rid of it. So 5x divided by 5. Listen, let me say this too. I've seen this over the years a lot of times. You're not dividing by x. You're not dividing by x because why would you divide by x? You're not trying to get rid of x. You only divide by what you're trying to get rid of. If you're trying to get x by itself, why would you mess with the x? Don't mess with the x. Again, think logically. When you're doing math, think logically. All right? So we divide by 5 on the left-hand side. We also going to divide by 5 on the right-hand side. So 5 divided by 5 is 1. 10 divided by 5 is, make sure you know your division facts. 10 divided by 5 is 2. Don't make the mistake of subtracting instead of dividing either. So I got negative 2 and positive 2. Negative 2 and positive 2. So now we go up here, and we're going to check to make sure that these are true solutions and not extraneous. Let's see what happens. So 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. The absolute value of negative 10 is positive 10. With absolute value, all negatives turn positive, all positives stay positive. Positive stay positive, all negatives turn positive. Positive stay positive. If you're already positive, you stay in positive. Good vibes only, right? Negatives become positive. Fix your face, right? Fix your attitude. Negatives become positive. Now over here, 2 times negative 2 is negative 4. Negative 4 minus 6 is negative 10. Is positive 10 equal to negative 10? No, it ain't. Positive 10 is not equal to negative 10. So that means this is an extraneous solution. Extraneous. Excuse my handwriting. But you get the point. It's an extraneous solution. All right, now let's check positive 2. See what happens with positive 2. Let's see what happens with positive 2. So with positive 2, right, we got 3 times 2, which is 6. 6 minus 4, which is 2. The absolute value of 2 is 2. Over here, we got 2 times 2, which is 4. And then 4 minus 6 is negative 2. Once again, not a true statement. So this is extraneous too. They both extraneous. So what does that mean? That means that there is no solution. N dot S dot. No solution. There's no solution to this equation. Because we got 2 extraneous solutions. Even though we followed the algebra to a T. We followed it, all the steps correctly. Right? All the steps correctly. But this solution does not solve. We have a solution that doesn't solve. That's something Fred Hampton said, right? If we don't do the proper analysis, right? If we don't take account of the true situation that we're involved in. He said this back in the 1960s before the Chicago Police Department assassinated him in 1969 in December, right? In his house, you know what I'm saying, with his pregnant girlfriend, you know, and other innocent members of the Black Panther Party, right? He said, we'll have answers that don't answer, we'll have solutions that don't solve, we'll have explanations that don't explain. That's what he said. Dr. King also said something similar to that prior. So this is an extraneous solution, meaning it does not solve, it's a solution that does not solve the original solution, the original equation, rather. It's positive, so also extraneous, because it does not solve the original equation. All right? So yeah, so that's how we solve absolute value equations. But remember, you just got to create your two equations, set them up properly. The first equation should look exactly like the original equation. The second equation should look similar, but whatever's on the right-hand side, everything becomes the opposite. Everything becomes the opposite. Everything becomes the opposite. Positive 2x became negative 2x. Negative 6 became positive 6. Everything becomes the opposite on the right-hand side. On the right-hand side, not the left-hand side. On the right-hand side, not the left-hand side. On the right-hand side. Now, if the absolute value is written on the right-hand side, then, okay, whatever's on the left-hand side. Whatever's on the alternate side from where the absolute value expression was, that becomes its opposite. All right? So, yeah, I shouldn't say right-hand side because, you know, you might see a problem where the absolute value expression is on the right-hand side and the non-absolute value expression is on the left-hand side. You got to look out for stuff like that. All right? So, yeah. Once again, get some practice on these. And, again, shout out to my alma mater.